Good morning, I am Vincent Joly, Digital Solution Manager for Bureau Veritas Marine and Offshore, in charge of the digital classification program, which is aimed at transforming our operating model thanks to the digital technologies. I have an operational background of 20 years in the maritime industry in various countries for the construction and the inspection of ships, and I moved 4 years ago to digital transformation projects. During this session, I will present you our remote and augmented surveys. Our remote and augmented surveys are actually powered by augmented reality features and artificial intelligence model, but as a forward, I would like to inform that I will not speak too much on how the technologies are working, but more on the value provided in the services we deliver to our clients and the impact of their deployment for the business. In this regard, let's express the objective of this session as discovering how big organization like a classification society transforms his operating model by leveraging on digital technologies. Start before by a short introduction of my company. Bureau Veritas Group is a world leader in testing, inspection, and certification, with more than 78,000 employees in the world, with an activity in various markets like industry, building and infrastructures, oil and gas, automotive, agri-food, commodities, and consumer goods. However, for this session, let's focus on our activity on the marine and offshore market, which is the classification of ships and offshore floating units. What means the classification of ships? Simply said, it means the development of rules for the safety of the life at sea and the marine environment protection, the activity of ship design review, the inspection of ships during their construction in shipyards, the inspection of materials and equipment at manufactory, and the survey of the ships in service at port to ensure their proper maintenance and compliance with the rules. Our fleet now amounts to more than 11,000 ships. So the remote and augmented surveys we will now develop are related to the periodical and occasional surveys of the ships in service that we conduct through a worldwide network of 180 survey stations covering most of the ports of call. Our remote and augmented surveys actually mean 3 transformations. The first transformation, that we call See Remotely, is enabled by the use of aerial drones, ROVs, crawlers, and other robotics that we define as remote inspection techniques to provide the access to the area of inspection for our surveyors. During these surveys, our surveyors have to perform what we call the close-up inspection of the structure of the ship in a distance that should remain accessible with the hand. These remote inspection techniques enable the surveyors to access remotely to those areas that are usually difficult to reach. The second transformation, that we call Decide Remotely, or remote surveys, is the capacity for our surveyor to conduct his survey and decide on the status of the survey items from his office or from any remote location. This capacity is enabled by using live streaming solution and augmented reality features. Both transformations are disruptive in the way we operate because they produce digitalized data of the condition of the ship, which are progressively replacing written notes and PDF reports. The third transformation, that we call Augmented Surveyor, is an artificial intelligence model for automatic detection of corrosion patterns on pictures and video streams. This solution is consequently made possible by the data capture from the 2 previous transformations. Let's start by the first transformation, see remotely. What is the objective of using remote inspection techniques? Simply said, it means reducing the extent of costly and dangerous means of access, such as scaffolding, stagings, climbers, inflatable rafts, divers, by safer and more efficient means of access during the structural inspection of the hull. These remote inspection techniques could be either poles or aerial drones or crawlers or small ROVs that carry not only the eyes of our surveyors, but also various measuring instrumentation. For the adoption of these remote inspection techniques, we have deployed a test and learn strategy in 3 steps. First, we test the technology in simulated conditions to assess its potential and limitations for our use cases. Then, we confirm the value for the business in real survey conditions through proof of concept in order to compare the performance of the technology with the traditional way to inspect. And finally, we embark pilots for the deployment of the technology during real uncredited inspection. This strategy enabled us to remain agile and quickly move from test to production. So you can see here our roadmap of all those tests, POCs, and pilots we have conducted to test several technologies and to combine them together. For the second transformation, the decide remotely, and that we call also our remote surveys, what I have to say is that before COVID-19 happened, we spent time to define scope, what could be our solution, what could be our operating modes, and what should be our organization. All this internal preparation resulted to the situation that we were fully ready when the COVID-19 happened. The pandemic was not at the origin of the remote surveys, but just an accelerator for the deployment of the solution. It actually demonstrated the yield of our new operating model for the continuity of the maritime activities that never stopped during the COVID. And today we can see that remote surveys are a new normal. We propose either a full real-time or partly real-time operating modes to adjust the live streaming with the available network signal in the various inspected areas of the ship. This point is very important because the hull structure of the ship makes a significant barrier to the 3G or 4G signal. For an optimum client experience, we have streamlined and digitalized all the processes and workflows from the survey request up to downloading the final report. We have also rearranged our internal organization, our working procedures, by launching a worldwide network of 8 remote survey centers covering all the time zone, which enable us to deliver our surveys 24/7, anytime, anywhere. For the live streaming solution, we have benchmarked and tested several platforms available on the market. The process is very simple. The client simply calls our surveyor from his smartphone, receives an SMS with a link, and the client is immediately connected to our remote surveyor. The solution is fully transparent for the client. It is a WebRTC technology that does not require to download any app or subscribe to a license. It does not request to purchase any equipment, and it provides an optimized live streaming based on the bandwidth available on board the ship to ensure a continuous communication while the operator is moving inside the ship. It is also enriched by augmented reality features, such as the capability to anchor notes and descriptions on the video stream, take measurements remotely, etc. We did also a proof of concept of remote surveys with more advanced augmented reality features with an engine room, combining the use of mixed reality with Microsoft HoloLens, improved connectivity in the engine room of the ship, cloud point 3D model of the engine room, digital twin of the engine room enriched with smart data. This proof of concept was a success, and it may represent the future evolution of our remote surveys for new designs of ships, as it enables our surveyors and the client to access quickly and simply to a single point of truth for all the historical inspection and condition data captured during the surveys. However, today, it remains an experience on the pilot ships, as it needs significant investment cost on client side. Let's talk now on the third transformation, which is enabled by the data generated from the remote inspection techniques and from the remote surveys. Augmented Surveyor is a solution driven by machine learning that enable to automatically detect and assess the severity of the corrosion from the pictures and video streams captured during the inspection. Beyond the complexity of the algorithm, the challenge that we also addressed is the capacity of the model to operate on the edge. Why? Simply because our surveyors, they have to take their decision on board at the time of the survey, to inform on the area to be repaired, but not after coming back to their office when they could have access to the cloud computing power. Practically speaking, this means that our model is capable to be deployed with drones in real time, without access to internet and with normal computers. The solution provides a support to the decision of our surveyors and is building a collective intelligence by securing and capitalizing the experience of all the community of our surveyors. Let's summarize now the impacts provided by these three transformations. We deployed remote inspection techniques because it improves the safety of our surveyors and operators on board. It reduces the cost of the means of access. It provides better anticipation of the extent of the repairs. It saves time for the execution of the survey, and it improves the quality records. We can propose remote surveys services that provide a surveyor available anywhere, anytime. It is also saving transportation cost, reducing logistics, and reducing carbon footprint while improving the safety of the ship. We have developed an artificial intelligence solution called Augmented Surveyor that is capable of being deployed on the edge. It is partly automated. It will continue to improve thanks to the machine learning model. And it is leveraging from individual experience and knowledge to build a collective intelligence. To conclude, as a takeover, I would insist on start small and move on test and learn mode to explore quickly and to ramp up from test to POCs to pilots. The difficulty is always moving from POC to a real pilot. Artificial intelligence, it is not magic. It needs well-defined use cases and business objectives. These developments are to be considered in the long term and need to be carefully defined and assessed before losing time and money by multiplying the POCs that are never industrialized. Second point, data is an asset for artificial intelligence. We used to say no data, no AI, and bad data, bad AI. AI development also needs much more business resources than any other digital project. So we cannot have a project organization for AI like what we have for any other digital project. It needs also a well-prepared deployment strategy in order to move from the POC to an industrialized solution that could be adopted by the market. For big organizations, COVID-19 was an accelerator for the deployment of the remote capabilities, but only those who were prepared before have demonstrated the yield of their business model. Finally, and it will be my last conclusion, digital transformation is not simply implementing new technologies, but it is more the matter of transforming an operating model. Thank you, and I will now let the room for Q&A session.